Okay, guys, here's another homework help problem. I had a request for rotation 2, number 8. So we have two masses. There's a pivot point, and the rod that it's attached to is massless, so we basically are ignoring this. So if I start off this problem, I recognize that this mass, or the weight of this object, is going to cause a counterclockwise torque. And I'm going to call that torque 1. And then on the other side, I have the same size mass, so that arrow should be the same size, and it's making this thing pivot around the axis point in the clockwise direction. And the question is, what's the initial acceleration of particle 1 and particle 2? Well, the linear acceleration of those two particles is going to be different, but since they're a part of the same rotating system, their alpha will be the same. Remember, alpha is going to be measured in radians per second squared. So this basically boils down to Newton's second law of rotation. So the sum of the torques equals I alpha. Now we have to be a little careful here because there's two torques. We already discussed that. How are we going to figure out the rotational inertia of the system? Well, the rotational inertia is basically going to be the rotational inertia of the first particle plus the rotational inertia of the second particle. And in general, a particle's rotational inertia is mr squared. So M1 and M2 actually don't have the same rotational inertia because they're farther distances out from the center. All right, so here we go. So the sum of the torques, I'm going to do torque 1 minus torque 2 equals M times 0.23 squared plus M times 0.75 squared, all times alpha. Ignore my children fighting in the background of the video. All right, now the torque is force times radius, and so what I'm going to do here is I'm going to put R, so 0.23, times the force causing the torque. Well, the force causing the torque is mg. I can do that. Minus R, 0.75 in this case, times mg. It's handy that the particles are the same mass in this problem. And I get m times 0.23 squared plus m times 0.75 squared, all of that times alpha. All right. Now I'm just doing algebra at this point. The m's cancel because it's in every single term. This g is just 9.8. I have a whole bunch of numbers, and I can solve for alpha. Now, when I find alpha, that's not the actual question they're asking. Alpha is the angular acceleration in radians per second squared, and they ask for the linear acceleration. So remember this very handy relationship, and in fact, the three relationships I'd probably put on my little note card for this, since it's open note, would be S equals theta r, not as important. V equals omega r, super important. A equals alpha r, really handy. So I'm going to use A equals alpha r so that I can find the linear acceleration for both of those objects. All right, guys, hope that helps.